Hi, pal. This is Tony Lockwood. I'm in Cleveland, Ohio. I am looking at the Rock and Roll Hall of Fame. It's got a nice windmill going around there. And I'm looking at the field where the Cleveland Browns are set to play football. This is coming to you from CAASE 2018 is what that 18 means for some of you slower learners. It is co-hosted by Digital Engineering, which I represent, and by NAFENS, which is the International Association for the Community of Engineering, Modeling, Analysis, Simulation people. And if you don't know about them, you should, and become a member. I have a very interesting discussion coming up here. Shawn, I'd like you to introduce yourself and where you're coming from,
Sure.
and tell us all about it.
Sure. So my name is Shawn Midlam-Mohler. I'm a professor at Ohio State University in the Mechanical Engineering Department, and I'm also the director of the Simulation Innovation Center, which is kind of the role that brings me to this conference.
Okay. And so you're also a fellow, though, aren't you? At the,
Yes, I'm also affiliated with the Center for Automotive Research, which is a experimentally focused automotive research center at Ohio State.
Okay, and all of that means is that he's a very smart guy, and I'm nervous because he's going to grade me. He told me he's going to grade me at the end of this. All right, so you...
So far, it's a B.
B,
just saying.
B. Okay, yeah, thank you. I've been called a... Well, never mind. All right, now, let me say, so much interesting stuff is going on in this conference, in the whole modeling simulation world. What is going on here? There's so much is going on here. Democratization, high performance computing.
Yes, simulation really came on strong with the advances in computational power. Mm-hmm. So the competitive cost forces trying to basically reduce prototyping cost and the complexity of products, all these things are really driving engineers to use more and more computational tools. If you think of an example of like an automotive crash test, very expensive to build a prototype vehicle, and what do you do with it? You smash it.
Smash it up.
Right? So if you have to do iteration after iteration of this, it gets expensive very quickly.
It does.
So in cases like that, you can see, why these tools are getting more popular. Yep. And from the education side, it's one of our jobs to make sure that the students coming out of our universities are equipped to actually use these tools effectively.
Yeah, that's also going to get into the university angle, because you're teaching the next generation of engineers, and the ground is changing so quickly.
Sure.
And these guys and gals are coming out of the school, and I'm presuming that the auto people, auto companies, and the tier 1, tier 2s, are all over them.
Yeah.
But what are the challenges that you have as an educator dealing with these students? Are you undergrads or grads?
So we do both. So we have both undergrads as well as graduate students. So a lot of what we do is focus on research. Mm-hmm. So that tends to involve more graduate students. Mm-hmm. But we're also very focused in shaping the curriculum at the undergraduate level. Mm-hmm. And some of the challenges we face are, because things are moving quickly, we have to try to stay in front of it, or at least at the same pace. And that can be a challenge, because developing new courses is a lot of work, and keeping up to date with all the licensing and everything to keep the lab stocked with the right stuff. It can be a challenge. So we do our best with that. But we also instill in our students a really strong imperative to do lifelong learning. So that they know when they leave that they have a strong fundamental background, but we also make sure they know that the ground's shifting, and you got to as you get into industry, you got to make sure you stay on top of things, or else you could be left irrelevant very quickly.
Very quickly,
Yeah.
you become a dinosaur.
Yeah, and
I'm only 30. Wait, what?
Yeah. So one of the other things we're doing is we have a professional development program that we're launching. That's one of the things we're here to promote. Is where again we're focusing on practicing engineers. So people who've already left the university are in roles and need to upfit their CAE skills.
Right.
That's one of the niches we're trying to fill. We're trying to.
Now, is this it would be a web-based?
Yeah. So it's distance-based, and the idea is to augment the traditional software training that people can get from many of the sponsors of this event.
Right.
And kind of take the traditional brick and mortar institution where you're learning the nitty-gritty details that you can't really get in a software class, but you need to understand to be the best possible user of that software. We're trying to marry those together in a distance-based format, and the students end up having a certificate from Ohio State University at the end of it.
Yeah, I think that's great because, as you said, you have to be a lifelong learner anyway, and the certificate's very important because you have it on your resume,
Sure.
okay? And, it's for you young people. You get it all on your resume, and it's going to help you. Take my word for it, as they say. Now, there's all these issues that are being discussed here at the show. Model complexity is just like going through the roof. It's like people want to do systems of systems, instead of just a part. It has evolved, from small systems to now. Let's simulate the whole automobile.
Sure.
And wait a second, that is a big computational issue for one, but it also is drawing in all sorts of disciplines that the person who you would call a structural engineer or a flow guy or electromagnet,
they're having to work together.
They all have to work together
sure.
and have at least a fundamental understanding of what those guys are doing. How do you approach that? I mean, that's a tough issue from your point.
There's a strong move on the software side, and you'll see a lot of the major software companies trying to put together suites of tools where in the past you had a fluid solver and an FEA solver and a system solver. And there's a strong move to try to get these things, at least in one harmonious tool chain, right? So to break down some of those barriers, but you're still stuck with the fact that traditional educational programs generate people with degrees in mechanical or aerospace or you name it.
Yep.
So at universities like Ohio State and many others, there is a strong focus on multidisciplinary. So we encourage our students to take classes outside their major. There's lots of extracurricular activities where students are mixing and doing real life projects where they're actually building stuff. So they have that natural inclination to start having those conversations.
Right, they do.
And I think it's really, again, it's really about letting the students know that this is important. You're not just a mechanical engineer. You need to be able to talk to those E's.
Right, those days are gone.
No, So it's... And also understand the limitations of the softwares in the current state. And they keep moving so fast, though, these things are starting to gel and come together as true kind of comprehensive. You can do any type of analysis. When you do electromagnetics, it's there already.
Right.
So they're coming together, and that's been enabled by, again, the computing power.
Yeah, and I think you just hit upon where I was going to ask you about, in the next few years, you're a futurist as much as you are a todayist, so to speak, because you're preparing people for tomorrow, but you have to know about today, and I don't want to say best guess, but we'll say best guess. Where are we going to be in 18 months, 2 years?
Sure.
The freshmen in high school now in 4 years showing up,
Yeah, so I think some of the technologies, in the siloed areas, as we mentioned, the simulation capabilities are pretty high right now. I see definitely more integration of multiple types of physics in the packages, and I think you'll see a lot more ability to wrap optimizers around those to actually assist the designer in making changes to parts. Because most type of optimizers they require repetitive runs of the model over
Right.
and over and over and over again.
Right.
And that's only possible on certain areas right now.
Right.
So once you get these more powerful tools with more powerful computers, that's going to open up a whole new field.
Right.
And that's when things like AI, like the plenary talk today comes in. You start bringing AI into this as well.
Right.
And it can allow a designer to be that much more powerful in terms of being able to design parts that truly meet an overall need and are integrated into the other systems on the vehicle or on the aircraft or on the
whatever.
you name it. Yeah. So I think that those three things: the inclusion of more physics in common packages, the use of optimizers, and then artificial intelligence coming in to allow us to just do things faster.
You're obviously into this.
Oh yeah, it's good stuff.
What's your favorite?
So
What really gets you going?
Yeah, so I am I do systems work primarily. So I don't do much of the high fidelity FEA or CFD. So what I like to see in the projects we do is that cradle to grave, from that initial design, the wide open space where you've got everything
Right.
you can do, and see that with design constraints narrow down using simulation to guide the design, and then making the systems, realizing them in a vehicle, for instance,
Yeah.
and then making sure, again, boom, we met our requirements. So
Yeah.
if you can have students go through that entire process, which is what they need to see that or have the
that's what they're
perspective.
going-
That's what happens.
Yeah.
That's what I get excited about, is taking it from those initial high level conceptual operational requirements all the way through that system engineering process, using models to do it.
Yeah.
That's to me, that's the coolest projects that we work on.
Oh, excellent. And let me see, the website I have for you is Simcenter, as in simulation center, that's one word, .osu.edu.
Correct.
Correct?
Yep, that's us.
You go there. I was wandering around the site. They have a lot of good information there. And remember that professional development business.
Course is on sale now.
The operators are standing by. Shawn, thank you so much
thank
for
you.
your time. This was great fun.
Fantastic.
Fascinating. Thanks, pal. We'll see you again.